quick revision for your midterm exams for the last term in 2025-2026, guys. Year 7. Let's go. First of all, we're gonna go for converting measurements. It's a really important topic, as we know for a fact that 1 meter is equal to 100 centimeter, and that 1 kilometer is equal to 1,000 meters, right? And we know for a fact that 1 centimeter is equal to 10 millimeters. So if I want to go from centimeters to millimeters, I'm going to multiply it by 10. If I want to go from meters to centimeters, I'm going to multiply by 100. If I want to go from kilometers to meters, I'm going to multiply by 1,000. And the other way around is going to be by division. So now, look at this part here. So if I want to go from meters to centimeters, I'm going to multiply by 100. If I want to go from kilometers to meters, I'm going to multiply by 1,000. If I want to go from centimeters to millimeters, I'm going to go multiply it by 10. This, guys, is called something scale factor. This is called scale factor. Okay. And if you're going to want to go back from centimeters to meters, you're going to divide. And meters, kilometers, you're going to divide. And millimeters, centimeters, you're going to divide by that same number. It's really important, guys. From meters to centimeters, multiply by 100. From kilometers to meters, you're going to multiply by 1,000. From centimeters to millimeters, you're going to multiply by 10. For weight, okay? We know for a fact that 1 kilogram is equal to 1,000 grams, right? So from kilograms to grams, you're going to multiply by 1,000, isn't it? And if you're going to go back from grams to kilograms, you're going to divide by 1,000, okay? The next part here, guys, is compound shapes and finding the area of a compound shape. Here, this is a compound shape in front of you. It has 2 rectangles, okay? You're going to name them A and B. You need to find the area of the first rectangle, and the area of the other rectangle, and you add them up together. So the area of any rectangle is length times width. But here we have 2 rectangles. We call them area of A and area of B. And you're going to add them up together. Okay. As you can see, the dimensions of area for the rectangle B are ready. We have 3 and we have 5. 3 is my width and 5 is my length. And the area of rectangle A is not ready because we only have the length here, as you can see. But look at this here side. It's 11 centimeters, including B and A together. And we have part of it, which is 5, which is for B. What's left of it is for A, which is going to be 6. Mr. How we got it? Because it's 11 minus 5. 11 minus 5. It's going to give me 6. So that 6, guys, is the width for rectangle A. So now I have my dimensions. I have the dimensions for A. I have the dimensions for B. All I got to do, I have to multiply now. After multiplying, I'm going to add up the areas. As you can see, 7 times 6 is going to be 42. 7 times 6. And we have 5 times 3, which is going to be 15. Add them together. It's going to be 57 centimeters squared, which is the unit measurement of area. Squared, guys. Okay. Then we've got a very important topic, which is the faces, the number of faces, edges, and vertices in 3D shapes and 3D solids to be accurate. And we have cube, we have cuboid, and we have triangular-based prism. So start with the cube and cuboid. They share the same characteristics, the same number of faces, the same number of edges, the same number of vertices. So let's say that's the cube, okay? Cube has the same length. That's why you call cube. If it doesn't have the same length, we're gonna call it cuboid. But they do have the same faces, the same vertices, the same faces, vertices, and edges. And guys, here it's really important to know for a fact that this is called vertex, plural vertices. These are all here vertices, the corners basically. And these are called edges. So that's an edge, edge. Mr. Edge side, yes, correct. And this is called face, and that's 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 called face. So these are faces, as you can see, guys. The really important parts of any 3D solid. And we have here, for example, another shape, which is triangular-based prism. It has a triangle in its base. And as you can see, guys, it's really important to know that faces and edges and the vertices of that shape. So let's start with the faces, or the number of faces, and the number of faces, and sorry, the number of edges and vertices for cube and cuboid. As you can see, they're the same: 6 faces, 12 edges, and 8 vertices for both cube and cuboid. Let me show you this on the cube. So we have 1 face, 2 face, 3, 4, 5, and 6, right? So we got a 6 faces, as you can see here, guys. We're gonna have 12 edges, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So we have 12 edges, as you can see. Vertices, we're gonna have 8 vertices, so 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. As you can see, guys, it also works for the cuboid. As for triangle prism, you guys, it's really important to notice that it has what, guys? It has 4 faces, 6 edges, and 4 vertices. Let me show you. 4 faces because 1, 2, 3, and the fourth on front, which is 4 faces. And we're gonna have 6 edges, which is gonna be 1, 2, 3, 4, 5, 6 edges, and we're gonna have 4 vertices, which is 1, 2, 3, and 4 vertices, as you can see in front of you. So you need to memorize them, guys. You need to try to draw in the exam. It's really important, guys. Let's go back to the arithmetic sequence. We have sequences. We have a lot of types of sequences. And we have arithmetic, we have geometric, we have Fibonacci, and you have a lot of one. So we have the arithmetic sequence that you can see in front of you, guys. So that's called an arithmetic sequence, okay? Because it's adding up with a factor, or call it the common difference. This common difference here, it's by addition. By addition, we are adding. And since we are adding or subtracting, we're going to call it ascending arithmetic sequence. So we need to identify this sequence as whether it's ascending or not, whether it has a common difference and what's its value, and what's the first term and what we call it. So if you want to go from 4 to 6, obviously we are adding 2 here, guys. Each and every time we are adding 2, guys, as you can see here. So how you notice that, Mr.? By taking the second term and subtract from the first term. So 6 minus 4 is going to be 2. So taking the first term, subtract from the 6. The second term is going to be 2, guys, as you can see here. And the same, 8 minus 6 is 2. 10 minus 8 is 2. 12 minus... Oh, so that's called the common difference. So the common difference for this sequence, guys, is going to be 2. And the first term, which we call it A, that's D, common difference. The first term is 4 in the sequence, so we call it A. The value of the first term is A, we call it A. So it's going to be 4 in this sequence. Remember, the common difference, it can be multiplication. For example, if you went from... for this sequence, for example, let's say 3, and then we have 15, for example, and then we have like so on, okay? So what's the difference here? How 13 became 15? As you can see, guys, you will know for a fact. You either gonna say, I'm gonna add it with 12, which is a really, 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 really good guess. But you would look at it in another way. So we need the rest of the sequence to know for a fact that it is actually by adding 13 or not. So we need the third term here. So let's say this one here is 75. Oh, so it's possible to be 12, right? Because 15 plus 12 doesn't equal to 75. So it's gotta be multiplication. So that kind of sequence is called geometric sequence. So we get each and every time multiplying by 5, as you can see, guys. Each and every time multiplying by 5, guys. So that's called geometric sequence. Therefore, the common difference is, as you can see here, by multiplication of 5, which is really, really, really important here, guys. But this is not notified as a common difference. Rather than that, is honestly, to be honest with you, it is more of a factor here, guys. But I need you to focus on what type of, you guys, the common difference when we are adding and subtracting. As you can see, whether it's ascending, so we are adding, or descending, so we are subtracting. Maybe 12 can be a first term here, and be by subtracting. What to focus, Mr. on the exam? The common difference, we know how to do it, and the first term. Good luck.